First question is in a large font. Okay. The first question is 2 log. What's my problem with this? There's a 2. What happens if there isn't a base?
10.
10. Should I write that every single time?
Yes.
Yes, because it will help you. If you write base 10 each time, it will screen put me together. If you don't have the base 10, I'm not joking, half of you won't put them together. It won't screen put you together as much as base 4s would. But if you were writing 10 and then 10 and then 10, that's a huge hint to you to put them together, correct? If you're writing the 10s below. Also, if you want to convert a log to exponential, you're going to need that base 10. So if a log does not have a base, you need to put base 10, right, Cooper?
Yes, absolutely.
Yes, absolutely. Yeah, totally. Totally. Yes. Oh, there we go. So, what's my problem, Cooper? You're going to help me. What's my problem? Numbers in front. What can I do with them?
The integers or the a and the b.
Yeah, you can put it as an exponent up here. I should put it with the actual number inside the bracket. What am I doing? That's a 3. That's a 2. That's a 4. I got aggressive with the 2s. Okay, so now they're together. What can I do, Cooper? Log base 4.
And then you can put the positive with the plus to the numerator.
Yes, so a squared and?
Three.
That's a 3.
3.
Yep.
And then you can put c squared and a4 in the denominator.
Yeah, were you stuttering? Because those are super clearly written. I have no idea why you're having problems with that.
Same thing.
I'm colorblind.
They're perfectly written, too. So I don't know why you're having any problems. Like, those are just perfection. All right. Now you know what it's like marking tests. That's what I see. Okay. So the a squared and the a4 cancel. I'm left with a 2 on the bottom. And I don't leave it like that. I will rewrite it. Log base 4 of b cubed over c squared a squared. What if they gave me b cubed over a squared c squared? Same thing. We agree? Actually, the exact same thing. Yeah.
Can you put a 1 in front of a b cube?
Yes, you put 1 in front of any of them.
Or whatever, and then...
Yeah, 1. 1 times anything doesn't change anything. Just note that it won't be there for multiple choice.
So you don't have to put a 1.
Right.
Okay.
Because 1 times b cubed, like this, crosses off and becomes a 1, but 1 times b cubed is just b cubed. Okay, number 2 was the challenger question on the page. So we go 2 log base a of 6 minus 3 log base a of 2. Those are screaming put me together because they're both base a. We agree?
Mm-hmm.
What do I have to do with the numbers in front? Raise them to the exponent using power rule. So the 2 comes up and we use it like power rule, and then the 3 comes up. And then we have plus 2 log base b of b minus log base c of 1 is what I told you to change it to a 1 as a typo, or write out. What happens when we have log base b of b? What is that?
1.
It's 1. Now, if you don't remember that, anyone with an old calculator will remember it. So the old calculators have problems because it's just more with brackets and stuff like that. It's more work, correct? But you guys will get these questions right more often because log base b of b is actually going to go into your calculator as log base b divided by log base b. We agree? Like log b divided by log b. And what's log b divided by log b? 1. So that's why that turns to a 1. Okay? So you can look at it as 2 times 1. You can look at it like this. Or I saw some people do this, which is not wrong. Log base b of b to the 2. Now what did I tell you if this and this are the same? Your answer is just the exponent. Now if you forget that, who cares? They gave you variables. They'll tell you b has to be an integer, or not an integer. They'll say b has to be a natural number. So you could go log, and I told you this, 7 to the 7 to the 2, you'll get 2. But you have to make sure the 2 is in the bracket. And you go log 8 to the 8 to the 2, and you'll get 2. And log 12 to the 12 to the 2, and you get 2. And then you'll be like, hey, I think log b to the b would be to the 2 would be 2, right? So you can test out things too. You're not just stuck if it's a variable and you don't remember the rule. So this is going to be 2 times 1. And then this one, the reason why is that c to what power is 1? C to what exponent is 1?
0.
0. So that's why the answer to this is 0. Remember your calculator does this to what exponent is this? C to the exponent 0 is actually 1. So this whole thing is 0. Once again, if you forgot. Wow. You could go log base 2 to the 1, log base 3 to the 1, log base 4 to the 1, log base 10 to the 1. You'd still get 0. So we can put these ones together. We're going to get log base A of 36 over 8, because 6 cubed is 36, and 2 cubed is 8, plus 2 minus 0. What's 36 divided by 8 reduced?
4.5.
Or 9 over 2. They'll most often have it as a fraction.
Can you put it with the decimals?
You can, but it won't match multiple choice.
Okay.
But it's not wrong if it's a written response. Okay, number 3. Bob, you can grab one of these. Number 3 is 64 to the x minus 3 equals a quarter to the 2x minus 1. You need to know this. You need to know that when I give you 2 bases and 2 exponents, and I ask you to solve algebraically, what's the only way you can do it? Common base. That's the only way I can ask you. There is another way. You log base 10 both sides and do a whole bunch of algebra, and it's like 3/4 of a page. It's outside your scope of your curriculum, so you don't have to do it that way. So if I give you 2 bases and 2 exponents, that immediately, and I say algebraically, it immediately tells you this can be common base. It's exactly what it is, because it's the only thing you can do. The only way I can give you not common base with 2 bases and 2 exponents is to ask you to solve it graphically. So say it was like 2 to the x minus 3, and then 3 to the 2x minus 1. I can't make them common base. I can only ask y1, y2. That's it. Okay? So the moment you have 2 bases, 2 exponents, you must be able to make common base. What base can I make them both be?
4.
4. So 64 is 4 to the
3.
3. And then x minus 3 I put in brackets so I make sure I distribute. 4 is 4 to the, or 1/4, sorry, is 4 to the
-1.
negative 1 to the 2x minus 1. So if I want a 4 to come up, or 6 to come up, or an 8 to come up, or whatever it is on the bottom, I raise to the power of negative 1. Then I have to remember to distribute. So I'm going to get 4 to the 3x minus 9 equals 4 to the negative 2x plus 1. Now my bases are the same, so I can set my exponents equal. 3x minus 9 equals negative 2x plus 1. Put my x's together. Add 2x. 5x minus 9 equals 1. Add my 9 over. 5x equals 10. Divide by 5. And x equals 2. How can I walk away from this question knowing I'm brilliant and I got it right? Yeah. Y1, Y2. Every solving question on your test. Y1, Y2. You can check them. Every single solving one. Heck, if it's a multiple choice, you could just Y1, Y2. Okay. So we'd put in 64 to the x minus 3, 1/4 to the 2x minus 1, second trace 5, enter, 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 and I would get 2. Number 4. Number 4 is 2 times 3 to the 2x plus 1 equals 8. What's the first thing I have to do? Divide by 2, because if this was a word problem, that would be the initial, the 8 would be the final, correct? We always divide that over. So we get 3 to the 2x plus 1 equals 4. Then what do? Can I make common base?
Convert.
No, if I can't make common base, I have to convert. This one matches this one, the one without a log, right? No log matches the one without a log. We agree?
Yeah.
Okay. So this is base, so it's going to be A. This is going to be X. This is going to be Y. And then I need the other one. X equals log base A of Y. So it's going to become X, which is 2x plus 1, equals log base 3 of 4. Whatever's beside your log, put in brackets. If it's not in brackets, make sure it is in brackets. If you don't have that 4 in brackets, go back into your work and put the 4 in brackets. Now, a lot of people get stuck here. This is just basic solving now. You just need to get x by itself, correct? That's ultimately the goal of solving. So, I'm going to subtract 1. And then I have 2x equals log base 3 of 4 minus 1. And then I'm going to divide by 2. X equals, I think it's 0.13.
Yeah.
And I could go back to this original with the 2 and go y1 and the 8 and go y2, not with the 2's in them, right? And second trace 5, enter, 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 and I should get 0.13. I should walk away knowing I have these or I don't. Should be happy or crying. There's no in between on these ones. Preferably happy, okay? So that is 2 bases, 1 exponent, can't make common base. Number 5 is the other example where I give you a log and I put the variable beside the log. Do you see how it's beside it here?
Yeah.
Do you see in number 6, I put the variable in the base? The only other option? I've given you an option of each type. Number 5, I put the variable beside the log. 6, I put the variable in the base. If the variable's beside the log or the variable's beside the base, I'm going to have to convert to exponential. That is my only option. Okay? When it's beside the log, it's a lot easier, just so you know. When it's in the base, you have to do like a root to get the x by itself. So the first thing I have to do here is divide by the 2. So I'm going to get log base 6 of 2x minus 1 equals 2. I have to have only 3 pieces if I'm going to convert. Now I need to convert to exponential. This one has the word log in it, so I'm going to write the log form beside it. X equals log base a of y. So this is log a, y equals x. And then I need to convert to the other one. Y equals a to the x. So now I'm going to get y, which is 2x minus 1, equals a, which is 6, to the x, which is 2. So 2x minus 1 equals 36. And then we're literally back to grade 8 math. What do I do next? Plus 1. 2x equals 37. Divide by 2. I could leave it as just 37 over 2. Or they could give the answer 16.5. I mean 18.5. That is not 36 plus 18.5. Now with logs, you always have to plug it back in and make sure that you don't get a negative beside the log. That's the key thing too. So before I boxed it, I should have went up here and said 2 times 18.5 is 37. Minus 1 is 36. That's good. Right? Because you can get extraneous roots. You can get ones that give you an answer but don't work. Also, if you're y1, y2ing this, you'll know if you get an answer, right? You should be trying these every single time in your calculator to check them. Okay, number 6 is a harder one. The moment, I'm telling you, the moment that your base is the variable, you're going to have to square root, cube root, fourth root, fifth root, 1/4 root, 1/8 root. That's what you're going to have to do. No, the moment that your variable's in the base, you are going to have to fifth root, fourth root, quarter root, half root, whatever. Okay? Because your exponent is going to be on that. So when the variable's beside the log, it's so nice. When the variable's beside the log, it's what goes by itself, right? But when the variable's in the base, it's what it gets raised to the power of. It becomes a base. So it makes it harder. So we're going to divide by 8. And we're going to get log base x plus 1 of 6 equals 1/4. Or 0.25, some people put, which is fine. The moment the variable's in the base, the variable's beside the log, I have to convert to exponential every single time. So I write, this is the log one, so I write the log formula beside it. And I match. Log a, y, x. So I get x equals log base. Nope. I get y equals a to the x. My brain stopped for a second. So I'm going to get y, which is 6, equals a, which is x plus 1, to the 0.25. Now if it's a quarter, which it was, you could raise it to the 4. Remember we said that and they would cancel? Or you can always just take the root of that because your calculator will do it for you. So if it was a 2, you take the square root. If it was a 3, you take the cube root. If it's a 0.25, you take the 0.25 root, which I know sounds stupid, but your calculator will do it, which is super nice of it. So you take the 0.25 root or the quarter root. It's the index. So I get the 0.25 root of 6 equals x plus 1, and then subtract 1. So I get x equals 0.25 of 6 minus 1. Now how do you type that in? You go 0.25, math number 5. 0.25, math number 5. Because when you press math number 5, it gets you a little square root button with the x, right? Everyone should be typing it in, practicing it. 0.25, math number 5. Yeah, you can still get it other ways too, right? If it's to a quarter, you can raise it to the power of 4. Both sides. Works perfectly. I like that way better. I lose most people with that way though. So what do you get? 1,200 and... 95. So many answers, so little time. So people, when they y1, y2 this, get stuck because they don't make their x max big enough. But if you are y1, y2ing to check it, paying attention, are you listening? This is very important. If you are y1, y2ing to check this, and I know the answer is 1,295, I'm going to make my x max be bigger than that. It has to be at least 1 bigger. So I'll make my x max be 1,296. And then I should be able to go second trace 5, enter, 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 and it should give me my answer. So if you get your answers first and check using your calculator, the windows aren't so hard. You just have to make sure your x max is at least 1 bigger than that. Okay? Makes it easier for your windows. Plus, you shouldn't be relying on your calculator because you're much smarter than that. Yep. Yep. Number 7. What happened there? Number 7 says Jacob invested $2,000. So that's my I. Into an RRSP at 0.05% per annum. Compounded semi-annually, so it's 2. And he made $300. Now, this is the thing. Compound interest is always 1 plus interest divided by CP. If it's 1 plus, your final needs to be bigger than your initial. And if it's not, it will fight you because you can't figure it out. Now, I told you, I gave you this one specifically because just in case they give you a type like this, you can't say, Mrs. Lepp, I've never seen it. You just did. Here it is. So, he made $300 interest. So, what's his final? I walk into the bank. I'm Jacob. Hello, hello. Here's $2,000. Okay? And then they're like, oh, hello, Jacob. Here's your $300 you made. And then Jacob's like, oh, thank you. And then Jacob walks out of the bank. What did he walk out with? $2,300. So his final amount is actually $2,300. If you use 300, it will fight you because it can't do it. You're saying I'm increasing my interest, but I'm losing money, which doesn't, the equation will fight because it can't work. And then it wants n to the nearest. Why am I putting a 3? Good question. I don't know. How many years? Nearest whole year. Question. So our final is 2,300 equals 1. Nope. I. 2,000. Bracket 1 plus 0.05 divided by 2 to the n times 2 or 2n. What I tell you, the first thing you should do if you have a final and you have an initial. Divide them. It should be what you do. Because whether you're using your calculator or you're solving by converting it to a log, that option has to happen or your Windows going to be really hard to find. Okay? Sometimes it's still hard to find, but it makes it a bit better. And to convert to a log, you have to do this. So you divide by 2,000, and you get 23 over 20, or a decimal, which 1 second, I'll deal with that in a second. Now you have to go 0.05 divided by 2, which is 0.025, plus 1. So I get 1.025 to the 2n. What does this turn out to be? 1.15. So I'm allowed to write 23 over 20, and I'm allowed to write 1.15 because it is a terminating decimal. I specifically gave you one later that is not a terminating decimal, it's a repeating one, prove that you can't take the rounded decimal. Sometimes you have to take the fraction. So here we have 1.025 to the 2n. Now, I am going to solve this algebraically every single time because I'm not going to rely on my calculator. I'll use my calculator to check it, but I'm solving this algebraically. Every single exponential word problem, once you have moved the initial over, if you're missing the variable in the exponent, this is only if you're missing the variable in the exponent. Every single time you're at this step, you'll convert to a log. Every single time. It's not like, what should I do? Convert to a log. If you're missing the time, you're missing the n, the exponent, at this point, after you've divided your initial over, you convert to a log. Every single time. So, you're going to have y equals a to the x, because this doesn't have a log in it. So I don't match it with the log one because there's no log. So this is my y, this is my a, this is my x. You only need to convert to a log though. Once again, I'm going to repeat myself. You only need to convert to a log if the variable's in the exponent, correct? If the variable's anywhere else, you can just use normal algebra to solve for it. So if you're missing I, you just take what's beside it and divide it by below the f. If you're missing f, you would just do all the math on this side, correct? If you're missing little I, you would end up having to do some other math to solve it out, like taking the square root or the cube root of whatever the n is. You only have to convert to a log when the variable's in the exponent. Often that's what they ask because that's the unit you're in and it teaches you how to convert to a log, right? So every single person on the diploma, if this is a written response, should be able to solve this by a log and not base it on y1, y2. And if you're still only doing y1, y2, start solving it with a log because that's what I expect from you. Okay, so we get x equals log base a of y. So I'm going to get 2n equals log base a, which is 1.025, and then y, which is 1.15. And then I just need to divide by 2. And what does n equal?
3 years.
2.93.
2.93?
It was like 2.83 or whatever.
83?
So you round it
That's
to
just really fast.
and then you round it to 3.
So it says here that they need, he needs to make the $300 interest. If I round it down to 2, is he making the $300 interest?
Negative.
No. Even if it was 2.1, I still could not round it down to 2. He would not make the $300 interest. So this is actually 3 years. What if instead of the years, though, I asked you for the compounding periods? What would you do? What if I asked for number of compounding periods? Do I take the 3? 3 is rounded. Do I take the 3?
No.
When am I allowed to round? In the answer. That is ever. Like in all of math. I don't care. If 30-2, when you go to the diploma, if you round anywhere before the answer, you're wrong. You can't be like, and could I be wrong? You're wrong. You just will be. And then you're getting your numeric response wrong because you rounded too early and the answer will be 16 and you put 17. And it'll be a sad day. And you won't even know it's sad. But it will be a sad day when you get the mark. So do not do that. You do not round till your very last step. Now this one ends up actually working out to the same answer if you had rounded. So you would have lucked out. But nonetheless, you take 2.83, whatever the decimal is, and you multiply it by how many times a year? It's doing this 2 times a year, right? Which would get me 5 point blah, 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 blah. It's a higher number. So it'll get you 6 compounding periods. So it ended up working out. Sometimes with semi-annually, you would luck out. If it's a low number, though, like say it was like 2.1, you wouldn't have lucked out. It would end up being 5 and you'd be wrong, even though you rounded to 6. Number 8. Kyla placed 6 bacterial cells, so I is 6, into a petri dish. The bacteria triple, so that's 3. Every 30 minutes, is that P or T? Every 30 minutes it's tripling, it's tripling, it's tripling, it's tripling. It's P because it's the period, right? Every 30 minutes this baby's tripling. So that is P. How long to the nearest minute? So T, will it take for there to be at least 5,000 bacteria? So that's my F. Now when it says at least 5,000, that doesn't mean put 5,001. It means put 5,000 and round up on your time. That's what that means. It doesn't mean go 5,001. I've seen people say like less than 5,000, they go 49999. No. You would just take your time and round down then if it was less than that, right? But if it says at least 5,000, you're going to take your time and you're just going to round up. So here we do our final, which is 5,000, our initial, which is 6, our R, which is 3, our T, which we don't know, our P, which is 30. Look, our variable's in the exponent. What are we going to do? Convert to a log every freaking time.
Divide.
But first we have to do,
Divide.
yes, divide the 6. I just penguin walked. I don't know why I did that. So this is going to get you some weird decimal that's like 0.3333333333. So what if you kept 8 decimals and rounded it?
No.
Mrs. Lepp would be inside your head being like, you're so wrong. No, 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 no. That's what she would be doing. I hope she's there for you. Because are we allowed to round before the answer?
No.
Nada. No. So in this case, I would actually have to keep the fraction. So I could either keep 5,000 over 6, or if you math entered it, you get 2,500 over 3. They're the exact same decimal. It doesn't make a difference. Okay?
25 over.
Yeah. So, yeah, but you can't put 3 repeating into your calculator. You have to go 2,500 over 3.
Can you just do 1 divided by 3 in bracket?
Can you do what?
Go wrong.
You need to just put the fraction in.
Well, yeah.
Yeah. No,
Do you have
there's
to
no other.
reduce the fraction before you put it in, or can you-
No, you can put in 5,000 over 6. Okay, so we need to convert. Stop typing the 700 decimals. That is not making you any better because you're going to write a rounded decimal on here and they're going to take marks off on you. It doesn't matter if your answer results in the same thing. You put a rounded decimal of like 383.33333 there, and then you put a dot, you're done. You're going to lose marks because it's not the same thing. No. Okay, so we have y, a, x, and so we're going to get x, which is t over 30, equals log base a of y, 2,500 over 3 or 5,000 over 6, doesn't matter. And now I have a division of 3, so what am I going to have to do?
Multiply.
Multiply, and by division of 30. Why did I say 3? I just ignore things sometimes. 30. And when I type that in, I get t equals a what?
183.6 dot dot dot.
0.6 dot 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 minutes, correct?
And then round up to 184.
Which is 184 minutes. Even if, you guys, please pay attention, because it says at least 5,000 bacteria, even if it was 183.0075993, it's 184. Because at 183, you would not have 6,000 bacteria. You would have a tiny bit shy. Okay? Okay, the last one. Number 9, Spencer and Cooper own a fishing pavilion. They have 40,000 fish. So I is 40,000. On January 1st, 2020. Their business is very lucrative, and as a result, their fish population declines because they sell them, not because they die. Lucrative. Making money. At 10%, so 0.10. In how many years, N, will there be less than 10,000 fish? So my final is less than 10,000. What's happening here? I'm going from 40,000 to 10,000. I'm depreciating, which means I have to do what?
Subtract.
Subtract my interest rate. So whenever your final is bigger than whenever your final is smaller than your initial, you should be subtracting, or you screwed up. Those are your two options. So in the compound interest, if you went 300 to 23 or to 2,000, you would have been wrong because you needed to add. Yeah.
So do you write 10,000 even if it says less than?
Yes.
I got
You're just going to have to round up your years to get less than 10,000. That's all. Yeah. You won't put 9999.
Yeah.
It just means, hey, here's my years. I need to round up to make sure I'm below it. Okay, and then we have 1 minus 0.10 to the n. Wait, look, I have an exponent that has a variable. What am I going to have to do after I divide by the initial, since you guys tapped me last time?
Convert.
Convert it to a logarithm. I feel like a broken record, but that's okay. You don't know what records are. Records are these things, and you put on a turntable, and you put this thing on it, and then it went around and it played stuff. It's becoming cool to have records now, so you probably know, but see? I'm not gonna lie, I barely had records, so I just remember seeing them, but I don't know if we had this big tall thing, and you could like lift the lid up, and then you put a record on it. It was a bad boy. It had like speakers and everything built in. It was quite hip. Okay, so you guys, you're going y1, y2 all the time, but instead of y1 and y2, I want you to please convert. So this is going to be y, a, x, x equals log base a of y, which is a quarter or 0.25, it doesn't matter. And what do we get?
13.157.
157, blah, 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 years, which is actually 14 years. You know why it's so lucrative? Because these fish are still having babies, you see. There's some fluctuating thing going on here. We just don't know it. We're just doing it on a complete disgrading scale of some sort, some decay. All right.